Welcome to doassignment-ca. Here is the problem. The velocity of a particle traveling along a straight line is v equals 3t squared minus 6t in feet per second, where t is in seconds. If s equals 4 feet when t equals 0, determine the position of the particle when t equals 4 seconds. What is the total distance traveled during the time interval t equals 0 to t equals 4 seconds? Also, what is the acceleration when t equals 2 seconds? Now, let us work through the solution step by step. We are given the velocity function v equals 3t squared minus 6t in feet per second. The particle starts at a position of 4 feet when t equals 0. We need to find the position at t equals 4 seconds, the total distance traveled over that interval, and the acceleration at t equals 2 seconds. To find position, we integrate the velocity function. The integral of 3t squared minus 6t with respect to t gives t cubed minus 3t squared plus a constant c. Plugging in the initial condition, s equals 4 when t equals 0, we get c equals 4. So the position function is s of t equals t cubed minus 3t squared plus 4 feet. Now we substitute t equals 4 into our position function. 4 cubed is 64, 3 times 4 squared is 48, and we add 4. That gives us 64 minus 48 plus 4, which equals 20 feet. So the particle is at 20 feet when t equals 4 seconds. To find total distance traveled, we need to check whether the particle ever reverses direction. We set the velocity equal to 0 and factor 3t times t minus 2 equals 0, giving t equals 0 and t equals 2 seconds. Checking the sign of velocity, between 0 and 2 seconds, the velocity is negative, meaning the particle moves in the negative direction. Between 2 and 4 seconds, the velocity is positive, so the particle reverses direction at t equals 2 seconds. Let's evaluate the position at each key time. At t equals 0, the position is 4 feet. At t equals 2 seconds, the position is 8 minus 12 plus 4, which equals 0 feet. And at t equals 4 seconds, we already found 20 feet. Now we compute the total distance by adding the absolute values of the displacements on each subinterval. From t equals 0 to t equals 2, the particle moves from 4 feet to 0 feet, a distance of 4 feet. From t equals 2 to t equals 4, the particle moves from 0 feet to 20 feet, a distance of 20 feet. The total distance traveled is therefore 4 plus 20, which equals 24 feet. Finally, we find the acceleration by differentiating the velocity function. The derivative of 3t squared minus 6t is 6t minus 6 in feet per second squared. Substituting t equals 2 gives 6 times 2 minus 6, which equals 6 feet per second squared. To summarize, the position of the particle at t equals 4 seconds is 20 feet. The total distance traveled from t equals 0 to t equals 4 seconds is 24 feet. The acceleration at t equals 2 seconds is 6 feet per second squared. These results follow from the fundamental relationships that position is the integral of velocity and acceleration is the derivative of velocity. Visit doassignment.ca for more study tools, AI learning support, and online tutoring.